Hello, my name is Gabriel Kelman, and today I'm going to be doing the Flow project for Professor Osbe's class. I'll be showing Poisson, Coet, and the hybrid of the both. For this one, I will be showing you the steps that I took to make them from my already finished results, and in an effort to save time so we don't have to wait for meshing and things like that because my computer happens to be very slow, but I have already completed the project and I will just be going through how I did that. So for this one, you want to start to create your actual pipe. You want to go into geometry. You want to make sure that this analysis is in 2D and not 3D. And then I already have it open, but here we'll go. It'll open up like this. For this one, for all of them really, it'll be completely blank. And then what you have to do is you have to go to sketching. You have to make your rectangle, and then you would start out, drag it, kind of like that, and then make that, and then your dimensions. I chose, as you can see down here, you would use these and these two tools. My dimensions, the length of it is 500 millimeters, and the height of my pipe would be 10 millimeters, just to make it so that everything is laminar for the Reynolds number, so that the number is 2000, so that the entire flow can be laminar. And then after you make all of your length and height of your pipe, that's all you have to do for this step. Not a lot to do here, just catting out your model. And so then after that you go to mesh. And for this one, you can choose to. For this one, I have it already open. So here you can see I already have it completed. So here, what you would do is you go to your your model. You click on both. You name every single piece. You click on the line, right click it. And then create name selection, and then after you do that, you would name it. I named mine like top wall or upper wall, lower wall, outlet and inlet respectively, outlet, inlet, upper wall, and everything. And then after you do that, you would then choose the mesh tool by inserting new mesh. Or you would, you would then take those two, you'd select up here, here, simultaneously, and then insert a new mesh using this menu, or by generating a mesh on selected bodies. And so here, I have it here where I chose these two edges. As you can see, two edges, no suppressed, and instead of doing it the other way, you choose number divisions. For mine, I chose 2500, which is why I won't be showing you the meshing process, because that usually takes a while, especially on my computer. So just for the sake of time, we don't need to capture curvature, capture proximity, and no bias, and we want to make sure that this is set to hard and not soft, so that everything is right. And then after that, we're going to match that on the other side using the inlet and the outlet. But this time it'll all be the same, except the number of divisions will be 50 instead of 2500. So because you only need to go it horizontally. And then after we complete that, it may look like there's just a bunch of bubbles everywhere. And so in order to make that look like a grid, like that I'll show you later, you want to do a face mesh, which can be found up here. You just click the face here, mesh, mapped mesh, make sure this is quadrilaterals, and then everything else should be default. And so after that, it may look like a giant black box, but once you actually zoom in, you can see it is a very just complex grid system. So that it can show you that where the flow is in each specific box right here. And then after that, you go to setup. Just a note, I'll mention this later, but the only difference between for this and the Couette and Poisson flow will be the length and the height. Everything else is exactly the same except for the length and height of my box. For Couette and the hybrid, it'll be 250 times by 5 millimeters versus 500 times 10. So after that, you open up solutions. You want to make sure that this isn't double precision, or when you double select here, it'll give you the option to then choose double precision. So here we can show you. Okay, that's fun. Here we go. As you can see, double precision. Wait for this to go away, and then there we go. Why would anything ever work well? We just have to wait for it to load in. Okay, so now that we're here, you would want to go to Materials, Fluid, click Air. Here you can see Air, and so for density, for all of them, I made sure to keep it 1 and constant, but for Poisson, I made it so that the density, or the viscosity, is 1 times 10 to the negative 5 to satisfy that Reynolds number calculation that you can see in my report. After that, you will then go to boundary, make sure that this is type, make sure this is velocity inlet, because since it's Poisson, it needs that little boost. And so for what I did here, I made it 0.04 meters per second, again, to satisfy that random number of getting a 200 or 2000 for Reynolds number, so that I can maintain it laminar. Also, you want to make sure that this is also in viscous laminar and not anything else, because if not, then obviously you will not be doing this project, and then we'll be doing that wrong. Then for after that, we'll go to results and then go to residuals. And here I already have it, but I made the residuals 1 times 10 to the negative 6, just to make sure that everything's good and everything's accurate. Then after that, you want to go to initialization, and then go to reference values. Apologies. Make sure they're computing from the inlet and nowhere else. So it starts at obviously starts at inlet, and the reference zone is the surface body. And also check all your values are the same, viscosity, and then your density, everything else is variable. And then after that, you would want to just do the hybrid initialization, initialize, and then your calculation, and then initialize, and then you want to run your calculation. Again, for this one, I chose 150 iterations. Usually I do more than that, like 200 to 500. Just to make sure that everything's accurate. But after that, you will be done with this step, and then you can, after that, you'll be done, and then you'll be able to know that you're done, because again, these will be check marks right here, kind of similar to this. The only reason they're not is because I'm making changes that I won't save because I already completed it. And then after that, you can go to results. Then I already have that open down here. And here you can see that I have a developing flow line, I have a midline, and I have my end line. So in order to make those lines, you go up here, show your line, midline, and then here you'd put in your points. So for here, for the midline, I put 0.25, 0.25, 0.25, and then you would be putting your height, which is 0.001, or 0.01, apologies. And then your number of samples will be 110. That's what I put. Again, I'm not going to do this because I already have it. As you can see right here, this is my midline. I already have that point. So there's no point here. As you can see, yeah, 0.25, 0.25, 0.001. And again, I do the same thing for the end line, like that, and then turn it, make sure it looks like this, where you can see 0.4999, so that would actually be at the end because it won't let us put it all at the very end at 0.5. And again, same, your height here, 0.01. And then for this one, I also did a developing flow just so that you can see, because by the time it's at the midline and the end line, it will already be developed. So in order to see in the graph it developing, I made this line 0.005, 0.005, 0.01, just putting it right here, 5 millimeters away. And then after that, you would go in, click this button right here, develop your contour, insert, OK, and then make sure that it all looks like this. Make sure it might start at inlet or something else. Make sure it's symmetry 1, and make sure the variable is velocity u, as that's what we're checking for the vertical velocity, or for the velocity profile. So make sure it's that and nothing else like pressure, which it tends to be. And the number of contours, again, I chose 110. I'll turn this back on. And then after that, you can see our Poisson flow. See, here's where it's developing up here. As you can see, not exactly developed. And then by the time it is developed, right here you can see. And also here is your legend that you can insert by doing this legend, and then change it how you want that. You don't really need to go into detail. And after that, you can go to your chart viewer. Yeah. So let us insert a chart. Not there, sorry. Just leave it like that. Yeah, you don't really have to label it if you want to. Poisson flow. Yeah, make sure your x-axis is your velocity u, since that's what we're measuring, and then your y-axis is your actual y value. And then after that, yeah, make sure it is showing the data you want. Oh, sorry, wrong one. And over here, show developing. Make sure it's also at the right location. Midline, again, at the right location. And then end line at the right location. Then after that, you can apply it. And then there you can see our Poisson flow diagram for the velocity profile. As you can see here, it really bulges out in the middle, and this is the developing line. And it might look like there's only the end line and not the midline, but if you were to take away the end line, you can see it change into your midline. So that will be it for the Poisson flow and how you make that. So I'll move on to the Couette flow, which will be a similar process. Like I mentioned before, the only thing I changed in the geometry and mesh, those first steps, were changing the dimensions from 10 by 500 to 5 times 250. So I won't be going through that, just in an effort to save time, because the meshing really is they're very simple steps, and it's the same as before, same number of divisions and everything. So we'll go here to setup. Again, make sure double precision is the thing selected. Just close these out to make it run better. It's just waiting for it to load. As you can see, this is why I did not want to make it from scratch, because my computer does not load things very well. So feel free to skip around. I hope you do, so you're not sitting in awkward silence. Alright, now that it's all loaded in, again, want to make sure that the fluid is air. And then for this one, I made it so that the viscosity is 1 times 10 to the negative 3 instead of 10 to the negative 5, to make sure that, again, everything is for the Reynolds number calculation. So that's done. Make sure here it is a pressure inlet and not velocity inlet, as there's not going to be an initial velocity because it's the Couette flow. And also you want to make sure that this is cleared to prevent reverse flow. So yeah, again, so there's no reverse flow. And then also here, you want to make sure the same thing, no reverse flow, right there. And yeah, make sure this is pressure inlet type. Then again, residuals here, they are unchanged. So yeah. Then after that, you want to go to your reference values, make sure everything's right, compute from inlet, your surface zone is right, check your density and your viscosity. You also want to make sure that unique to Couette and Poiseuille, you want to make sure that everything is right, since we're going to make sure that the lower wall is stationary and the upper wall is moving at the speed we want. So again, you go here, stationary wall, no slip condition. And then make sure, and then you're going to click on your upper wall. Since this is a moving wall, and again, we're going to make mine 8 meters per second and no slip right here. So we can then satisfy our Reynolds number equation to make it 2000. So it is laminar. And also make sure viscous laminar. And then yeah, compute here, make sure all your numbers are right, which they are. Again, do the same thing as before. Your hybrid initialization, initialize, and then you run your calculations. And again, number of iterations, that shows 150. Don't usually do that, but just for the sake of the video. And then yeah, that'll be it for this step. And then once you're done, you will go to your results. and this is where we'll make our contour and velocity profile, and with our charts, similar to what we did with Poisson. Alright, well we're back here to our Coet flow. Here, let me turn off the contour so that you're able to, wrong one, to see midline, end line. You can see here 0.125 since it's not 500 anymore, and the end line is 0.2499 instead of 0.25. Again, remember line, and then you put in all these numbers to make it right. Go to your contour, insert contour, make sure it is all symmetry 1, velocity U, and our contour is 110, and then boom, there's your contour. You can see at the beginning it's a little bit of developing, and then after that it is way higher speed at the top and very low speed or 0 at the bottom since there's no slip conditions. And then after that we're going to go to our chart viewer, and we will insert chart. I will name it this time because you don't really need to. Here, let's put our midline, and then end line, and our proper locations. And again, here I'll show you what happens if you don't change your x-axis. It just turns into these. So I will then change those to the variables that we want, velocity u, and then our y. And now you can see our linear velocity profile because it's a Coet flow, so the only thing pushing it is the top plate moving. And then after that you would export it for further analyzation, but I already did that, so there's no point. And that'll be it for the just Coet. And now we will move on to the hybrid. Again, I kept it the same values for height and length as Coet, 250 and 250 length, 5 height in millimeters, of course, and then yeah, so that should be it, and the same meshing numbers. So let's go to the setup. Again, make sure double precision and everything is right. Okay, now we have that opened. We will go check, make sure viscous laminar, then go down, fluid, air, here same density as all of them, and this time I made it 10 to the -4 instead of 10 to the -3 or -5 like I did for Poisson and Coet. And that should be it for right there. And afterwards, if you want to, again, you can make sure and check that the fluid is air. Just here, that's it. Boundary conditions are inlet. We want to make sure this is in velocity inlet instead of pressure inlet like we had previously. And so our inlet velocity I made 0.8 to satisfy, again, that Reynolds number, so it is 2000. So going into it, it is 0.8. Yeah, and then our outlet, you just want to remember prevent reverse flow so it doesn't mess up with your calculations. And then for your walls, you want to make sure that your lower wall is stationary and no slip, and your upper wall is moving and no slip. So stationary, no slip. And then for this one, I chose 0.6 for my upper wall velocity. See air, speed, 0.6, moving wall, no slip. Bing, bing, boom. Let's go. Again, remember, check your residuals. Shouldn't have changed. 1e to the -6. They shouldn't have changed. There's no need for them to change. Yeah. So, after we do that, we can go, actually we'll go to reference values to make sure everything's valid. Remember to have it so it competes from the inlet, and the reference zone is the surface body and nowhere else. Yeah, I forgot to mention that. Remember density, and then what is it? Velocity, inlet velocity, viscosity. Here we go. Everything else is fine. Then we can go to initialization, initialize right here, and then you can run your calculations. Again, 150. Usually you can do more, but again, just to make it easier. And then that'll be it for this step. Yeah. So we will then move on to the results and get our velocity profile and contour for our final, what was it? Our hybrid flow, the last thing we will be doing today. Just stay with me. So here you can see the completed one, but again, I will run it through you guys again, so can really contour. So here you can see the midline, end line, and I made a developing line again. Remember, to make a new line, you go here, your line, and then for the developing, you can see here my 2 points for the developing, 175, 0.005, so at the beginning when it's still developing, my end line, almost at the very end over here, and the height of it, and then my midline will be 0.125, again, right in the middle, who would have thought, with the height. And then after you're done with that, you come here, click your contour, click OK. For this one I'm not because I already have it. And then make sure that it's your location's right at symmetry 1 and velocity U. And then after that, you click apply with number of contours. And there you go. There is your final contour. And remember, insert, legend, there we go. And then after that, you go to your chart viewer. And we're going to make our chart. Oh, wrong one. So here you go. You can name your title whatever you want. I'm just going to leave it at blank for now because I don't have a use for it later. Again, we're going to put in our lines that we had before. With our location, and then our end line with our location, and then our midline with, you guessed it, our location. And again, I'll show you what happens if you don't change the lines. They're just straight because they're going off of values that aren't really affecting or aren't really getting affected by what we're trying to find. So again, remember, change your variable for the x-axis to velocity u, and your y-axis to y like we did for the previous two ones. And now you can see, boom, here's what it's supposed to be. You can see your developing flow right here, and then your midline and end line are overlapping again like they did for Coet and for the Poisson. And there you go. That's pretty much it. You export it. You can see, yeah, those are your graphs, so you save it, upload it in the document that I'll show here. Yeah, so here you can see that I found that the maximum velocity for the Poisson flow was 0.0059 meters per second, with a maximum velocity, or with the where its location was 0.005 meters up. See all the internets, the contour, and our Reynolds number equation. Then we can go to Coet. Same thing here. Maximum velocity is 8 meters per second, which makes sense because that is the velocity of the top plate. Then the height of it would be 0.005. Again, makes sense because that is the height of the chamber, or of the pipe, sorry. And here's our contour for that and our Reynolds number equation. And then for our hybrid, again, here it is. The maximum velocity was 1.08 meters per second with a height of 0.003 meters. And that should be it. Here is the contour and our Reynolds number equation. And that is it. Thank you so much for watching. Please be kind grading this, and I hope you have a good day. So long.